Nintendo Switch. This one supposedly has an error code of 21620002. My immediate concern when inspecting this Switch physically is this outer shield is dancing around. So it's definitely taken some damage. But the center row seems to be intact and I don't see any pins bent or broken. So I'm going to go ahead and plug power to this so that we can see if the error pops up. Watching the meter on your left, PSU channel 1. See if we get any signs of life. We seem to just be stuck at a 0.10. Now this thing has been sitting in a closet for a long time, so it is quite possible that this battery is completely stone cold dead. So my approach now is going to be to disassemble this enough that I can use my battery power squid to power this thing and see if it will give us the error code that we're expecting. And I will probably attempt to bring their battery back to life using my trickle charger assembly. I now have this disassembled enough to put to use my modified iPhone power squid that we have retrofitted Nintendo Switch battery connectors onto. We're going to activate using our OEM just real quick. And we are getting absolutely nothing. So I have a fear that this port is more compromised than we thought. There is some additional damage as well. I believe this was a repair attempt by another shop at some point. So as you can see, the ribbon has been ripped off the Joy-Con, and we have pry damage on the Joy-Con connector. I'm not sure if that can be saved or not, but we'll deal with that once we get some signs of life from the Nintendo Switch. I think the first thing we're going to have to address is this port, because I can't tell if we're having a port problem or a board problem at this point. We have the board out of the housing, and I want to do some preliminary testing just to be sure. Again, this may be skewed because of the port. We'll start around the M92T36, which is our PMIC. We'll begin around the capacitor that is connected to Pi 3 USB on the back of the board through M92T36. And the line we do not want shorted to ground is the line going to the chip. And we do not see a short. Now we're going to follow the lines to the chip on these capacitors around the M92T36. And we do not want them shorted to ground. This one is shorted to ground, so we are having an issue. Now, is that issue caused by our port or the chip? We will find out, because we're going to have to remove that port. And we have another short here. Now this capacitor here has two lines going to the chip, so one side will always be ground. This is our CPU cap. If it's shorted, it's usually not great news, but it seems to be okay. Let's check around our MOSFET area. It seems to be okay. Check our invincible fuse and see if it's still being invincible, and it is still being invincible. Now we're going to check our test pads. None of these test pads in this area should have a pathway to ground. If they do, we have an issue, and they do not, but we already know we're having an issue. None of these should have a pathway to ground. Now we're going to check this coil here and make sure it does not have a pathway to ground. It does not, but we do want it to have continuity through it. You sometimes have to work your way through the manufacturer residue, so do not be trolled by that. Now we're going to check around our BQ241A3. The BQ241A3 has several capacitors with two lines going to the chip, so just be aware that one side only should be ground. Okay, and we do not appear to have any more issues on this side of the board that we can tell. All sorts of issues around the M92T36 though. Let's go ahead and check around our Pi 3 USB, even though we did not show short on the other side. Real quick, I just want to make sure we do not have any shorts on our filters. None of them should have a pathway to ground. They should have continuity going through the filters though. But they should not have continuity going side to side. And we'll check our big capacitor. The line we're worried about is the line going to the chip, and that is this side, and it seems fine. Off the bat, I believe we have a problem with our M92T36, but the port is still an issue. It should not be doing this. This is not a feature of the USB-C port. So the first thing we're going to do is remove the port, and then we will test around the M92T36 one more time just to be sure that the port is not interfering with our readings. While I'm setting up to remove the port and while I'll be doing the port work, I am setting up my trickle charging board on their battery, and I will turn it on and see if it can do some work with this battery. You can watch the PSU channel 1 and see if we're making progress on the battery while we're doing the board work. We're set up in the board holder to remove the port. While I'm setting up my equipment, throw up my expected temperatures for this job. These temperatures are brought to you by the Amazon associate links in the description. If you click on any of those links and buy any of that equipment, or if you buy anything during that session, a small portion of that purchase will go to supporting the channel. It will not cost you an extra dime, and I greatly appreciate it. Alright, we will add some flux, and we'll be flooding these anchor points with the ingredients of low melt. See how our battery is doing, and we're down to an amp. What do you think? Do you think we will still have an M92T36 problem after we have removed this port? Let it drop. Get you a pull. Alright, moment of truth, guys. Do we still have an N92T36 issue? It appears we still have an N92T36 issue. Alright, so 1, 2, 3 shorted to ground on the lines going to the chip. My advice is not to even touch the chip until you see every pad around the chip go wet. And we should be good to go. Make sure we have no bridges around the chip. That can happen. You would want to clear those before you test. Find ourselves the ground and see if we've ever relieved our problem on these 3 caps. And it appears we have relieved our problem. Let's wet our solder and put a new chip on. When using this method, you want to make sure that center pad has wetted before you try to place the chip, and you want to make sure that the chip is making contact with that center pad before you let go. Make sure it's making contact before you let go. Turn it up, remove your heat, let it dry for a second, then put some pressure down on the chip, reapply your heat, and smash to the board, but don't do that what I just did. Put a little too much pressure and it slid, but we should be okay. Those marks on the side of the chip are alignment marks. You do not have to have the solder climbing up to those alignment marks. It looks nice and pretty, but it is not necessary for the function of the chip. That looks nice and aligned. That looks nice and aligned. This as well, looking good. Let's make sure we have not reacquired our shorts. And we have not. Excellent. Now we need to begin the prep for a new port. And you just want to glide over these anchors. You don't want to sit there and scrub. Pushing down harder on the wick does not make it work better. Go with the pads on this, and if you feel any resistance, stop moving. We're going to add a ball of solder to our tip. And we're going to run that ball over our pads. Not really trying to make any contact with the tip. Same method as with the pads. We're going to put a ball of solder and we're going to gently paint our pads. Nice and pretty. Place our port. I will be moving the nozzle rapidly. Looking like everybody's wetted. I'm going to let it go a little bit longer just to make sure we get those hidden pads that we cannot see. And I'm going to press down, remove my air. Those visible pins have dried. So we're just going to hold down for a tick longer. The hidden pins are surrounded by more material, so I like to give them a little bit longer to dry. I'm going to add a ball of solder to our micro pencil tip. That'll help get things flowing. And we're going to put a generous amount in these anchors. Those top 2 in this orientation take a bit more to get good feed through than these bottom 2. Excellent. Do want to check our visible pins, because when you're concentrating on soldering down that hidden row, you can sometimes neglect these guys. So it's a good idea just to do a welfare check. And they look good. Nice and solid. My next step is going to be to clean out the port. Rapid cleaning. So I just want to have a quick gander at this Joy-Con connector. While the plastic has been compromised, it does not look like the pins have been compromised. So I'm not too worried about it at the moment. Let's go ahead and do our power test. Alright, real quick before we steal away our USB-C dongle from the PSU. It looks like we're down to 0.98 on the PSU channel 1 amperage meter, which means this battery is coming back to life and taking a charge, so that's a good thing. Now we're going to perform a power test. What we want to see here is just a quick jump up in amperage and right back down to 0. Okay, that looks normal. And back down. Yes, that's what we want to see. And we want to see that on both sides, ideally. Looking good so far. Now using the OEM charger, we're going to activate the Nintendo Switch quickly. And what we want to see here is a steady climb in amperage on PSU channel 2, the amperage meter. And it looks like our Nintendo Switch is booting. Excellent. And we're going to see if we are docking. And there we go. We are docking. Excellent. I think board-wise we have solved most of our problems, but I do need to address that Joy-Con connector. I hope this video is being helpful to you on your repair journey. Just a reminder, if this is beyond something you want to try yourself, I offer these services. Just head over to micromage.repair, click on free quote, fill out the form, and I'll respond to you personally. Alright, I'm set up to pull a Joy-Con connector from one of my donors. There we go. Let's pull their connector. We are going to trim these up a bit, just to lower the temperature a bit. Pull the new one in. I think we're on there. As you can see, every pin on that side is nice and solid. Excellent. As is every pin on that side. Excellent. Our next step is to put the board back in the housing. So the battery had been uncharged during the whole repair. So let's just see how we did. We're using the PSU. We have a battery symbol. That is an excellent sign. And a Nintendo Switch logo. And we have touch. And we have sound. Test the Joy-Con we can test. Alright, excellent. We are back up and running. Strangely, it is not charging. Let me grab mine. Mine is charging just fine. So they may have an issue with their other Joy-Con as well. The battery could just be like incredibly low. While we're waiting on their Joy-Con to charge a bit, I'm going to double check and make sure we're charging on both sides. We should be, because we are docking. We know that. Fast charging on both sides, so I say their battery is savable. I put their Joy-Con on my Joy-Con charger. I have a little cradle that charges Joy-Cons. Let's see what's happening now. Okay, it is showing that it is now charging. So I think the battery was really low and it was too low for it to attempt to charge it. We are picking up the networks. Excellent. And Bluetooth is working. Excellent. Now, why are you showing low battery? Okay, we could still have a battery problem with our Joy-Con. The battery appears to be toast. It was showing full on my cradle. It was showing full back on here. It was showing like it was charging. But now we seem to have an issue. And looking at the USB meter in the center, we are happy. We are fast charging at 15 volts. Excellent. A little upset with y'all. No one told me I was putting this on backwards. Yes, I am blaming y'all. When you get a unit working, you really don't want it to go back and do more rework. The last pin looks a little dry, but we may be able to do that by hand. All those pins look good though. I can do this with a Jason Dilmer amount of flux. Okay, and it looks like we connected that last pin. Very good. Now I'll clean it off with my ultrasonic brush. As you can see, we are charging on the Joy-Con rail that we replaced and the connector we replaced. Excellent. And looky what I did. I was able to bring back the other battery from the dead. I'll explain how I did that momentarily. And sorry I didn't catch it on camera. I wasn't even sure this was going to work. So what I did is I had already retrofitted some wires to one of these USB-C trickle charging boards that I did a video on some time back. You can look back in my catalog. I unplugged the battery. I put the red lead on the red lead and the black lead on the black lead. Sometimes these batteries just get so low that the system cannot handle charging them. So sometimes it takes a little bit of outside influence to get them up to a point where the system can actually take over. It immediately started drawing about 1 amp and it quickly went down. That told me it was taking a charge again. So I put it all back together, put it back on the Nintendo Switch, and you saw the result. It is taking a charge again. Minus one screw up. That was an interesting repair. If you like this video, I think you'll like this one right here. And I'll see you there.